Right guys, welcome to CrosseMaths live lesson. This afternoon is Higher here. Okay, I'm just going to turn the comments off as normal. Have a go please, when you're ready, when you're tuned in. Have a go at starter on the next page. Today's proportionality. If you don't know what that is, that's good. Okay, because if you don't know what that is, that means you're probably going to learn lots today when you have a go at it. Okay, when you're ready, have a go. Okay, loads to do on today's starter. Okay, the starter will take up a big chunk of the session. Okay, I'll probably give you about 6 or 7 minutes just to get those questions done for me. Okay, make a start please guys. Right guys, last minute. Get as much done as you can. Right guys, then so I'll be super impressed if you managed to answer all those in about 7 minutes. Hopefully you got through most of them. The ones you missed, okay, the ones you got right, obviously take them. The ones you missed, please copy them down as we go, okay? So, first one, okay? Factorizing and solving quadratics, okay? So what I've got by here is a quadratic equation, okay? I've got to factorize this into 2 brackets. Now, it's the same as doing expanding double brackets, but it's going the opposite way. Now, I'm going to make this, I need 2 numbers to fill in these 2 gaps. I've got x squared, take away 14x plus 33. Now we need to find 2 numbers. You've got to multiply to make that one, and you've got to add to make that one. And they're going to go into 2 brackets by here. So 2 numbers are multiply to make 33, and add to make minus 14. So they can either combine to make 14 or have a gap of 14. 2 numbers that come straight to mind to make 33, because there's not many things the times together to make 33 are 11 and 3. And again, they can be added together to make 14, so that's perfect. They would both have to be negative in order to combine to make negative 14. And if they're 2 minuses, they will make a positive 33. So that works. Okay, all of that is going to be equal to 0. Okay, in order for this to be equal to 0, one of these brackets has to cancel out to make nothing. Okay, if the 2 things to times together, one of the brackets has to be nothing. If this bracket on the left is nothing, then x would be positive 3. If this bracket on the right was nothing, x would be positive 11. So those are the 2 values of x you could have to make this formula equal 0. That's 2 marks. Start us off. Next one. Okay, I've got some solving equations with unknowns on both sides. The first step is the most important. You get rid of the smaller letter. Okay, so if I got 2x and 4x, I'm going to get rid of 2x first because it's smaller. 4x take away 2x is 2x. Plus 3 moves straight down. 2x take away 2x is nothing. 17 moves straight down. Once you're there, 2x plus 3 equals 17. I'm going to take away 3 from both sides next. I end up with 2x moving straight down. All equal to 17 take away 3 is 14. And then if I divide by 2, x will equal 7. Okay, very straightforward question with 1. Easy 3 marks at GCSE. Once we're here now, this is the same as the first one. So we're going to be factorising into 2 double brackets. Okay, so the top one's going to make 2 double brackets. And the bottom one's going to make 2 double brackets. Because it's an x squared. Okay, so the top one are 2 numbers. They've got to multiply to make 6 and add to make 5. So I'm going to go with x plus 2, x plus 3. They multiply to make 6 and add to make 5. Perfect. On the bottom, same thing. They've got to add to make 6. And they've got to times to make 9, so it's going to be 3 and 3. Okay, once I'm there, you'll notice that these 2 on the top and the bottom match. If stuff matches in a fraction, you can cancel it out. So I end up with x plus 2 on the top. On the bottom, you end up with x plus 3. Very straightforward, okay? Again, 3 points at GCSE. Be right to the back of the paper. Easy marks, though. Okay, this is one of the topics we did on Friday, I think. So you've got to times this by 2 things. So I'm going to turn this into a formula. X equals 0.1474747, going on forever. Okay, I've got to times this by 2 things. I've got to times it by something to get both the recurrent digits over the decimal point. So I'm going to times it by 1,000 for that. So 1,000x equals 147.474747. ... Then I got to times it by something to get the first recurrent digit next to the decimal point. So I'm going to times it by 10 for that. Top times by 10. 10x equals 1.474747. And you'll notice there's that is the same on the top and the bottom. That's what we were trying to do. We were trying to line up the recurring digits with each other, so when we take away, they disappear. 1,000 take away 10 is 990. 147 take away 1 is 146. And top and bottom taking away, they cancel each other out. So you end up with 990x equals 146. If I divide through by 990, I get 146 all over 990. Does that simplify? I don't think it does. It might do. It might simplify once to 73 over 495, but I don't think it simplifies anymore. I think that's your final answer, okay? And that's it. It's a fraction. That's 3 points. 9 to the power of minus 3 over 2, okay? This is a similar one to before. It's indices. It's straightforward rules, but there's 3 rules going on. There's the minus rule, there's the power of 3 rule, and there's the divided by 2 rule. So 3 rules. Do them one at a time. I'm going to do the minus one first. All a minus 1 means is write the reciprocal of the number. So I'm going to do 1 over 9 to the power of 3 over 2. Okay, so the minus 1 just means 1 over the positive version of whatever you've got. Once you're there now, I'm going to do the bottom one. I'm going to do this divided by 2 next. Divided by 2, fractional indices, it means square root. So it's 1 over, square root of 9 is 3. So 1 over 3. The power of 3 is still there because I haven't used it yet. Anything to the power of 3 means times by itself 3 times. 3 times 3 times 3 is 27. So my final answer is 1 over 27. Next one, I was worth 2 points. Okay, bit of search. I think we had the same question last week. Square root of 45. That can be broken down into 2 things. Okay, similar to factor trees, where you've got to break it down into 2 things and multiply to make the number above. However, with this, you've got to use one of the square numbers. Okay, you've got to use a square number. So I'm going to break that down into square root of 9 and square root of 5, because 9 times 5 makes 45. Middle bit can stay as it is. That can stay as 5 root 5. This bit, I'm going to break that down into square root of 4 and square root of 5, with 4 being the square number by there, 9 being the square number with that one. Square root of 9 is 3. Square root of 5. 5 root 5. Take away, square root of 4 is 2. 2 root 5. This is like you working with x values. It's the same as 3x plus 5x take away 2x. Exactly the same thing. 3 plus 5 take away 2 equals 6 lots of root 5. And that's it for 1 mark. Very, very straightforward. Bit of trigonometry, okay? We do need a calculator for this one, okay? So, find x, okay? I think I've got a calculator with me somewhere. I'm not sure. Let's have a look in a sec. Once you're here now, this side by here, I've got to label my sides. That's my hypotenuse. That's my opposite. And that's my adjacent. Okay? Then, once I've done that, I write down SOHCAHTOA. I cross off the side that I don't need, okay? I need my 9, because it's got the opposite on it, and I need the x side, because it's got the adjacent. I'm going to get rid of hypotenuse, I'm going to get rid of it over here as well. So I'm going to be using TOA. I'm going to be using my tan triangle. It'll look something like that. Now, I need to find side A. So I'm going to write A equals or X equals, up to you. Then you cover the one you want. Whatever's left is you're working out. You can see now, if I cover A by working out, is O divided by tan. So my O is 9 divided by tan, 57. You pop all that in the calculator. Let's see if I've got one by here. I have a number of squeaky toes, but I don't have a calculator. If you pop all that in the calculator, you will get an answer for that one, okay? You may have to work that out yourself using your graphical calculator. I can't seem to find mine at the moment. Next one. Okay, I got 5x take away 3. 3y. Nope, we don't want that now. Definitely don't want squeaky toys right now. 5x take away 3y equals 16. And 4x take away 5y equals 5. Now, this is just basic simultaneous equations, okay? They are a straightforward topic. You just got to get good at them. Okay, I got to make the y's the same. Now, in order to do that, what I'm going to do, I'm going to times the top by 5, and I'm going to times the bottom by 3. What I'll do is I'll make both the y's into a 15. make sure you times every single thing on the top. If I times all the top, I end up with 25x. Take away 15y. 16 times 5 is 80. That's equation 1. 4x times 3 is 12x. 5y times 3 is 15y. 5 times 3 is 15. And I call it equation 2. Once I'm there, I need to take away these two equations to get rid of the y's. Okay, this is the bit I want to get rid of. If I take them away from each other, I end up with 13x. 80 take away 15 is 65. 13x equals 65. I know 13 goes into 65 5 times. 65 divided by 13, so x is 5. Once I know what x is, okay, and I'm going to do this bit up on the left-hand side. Once I know what x is, I'm going to substitute that back into one of these. I'm going to pick the top one. So I know x is 5, so 5 times 5 is 25. 25, take away 3y, equals 16. If I add 3y over this side, I end up with 25 equals 3y plus 16. If I take away 16, now I end up with 3y equals 9. If I divide through by 3, y would have to give you an answer of 3. That's worth 3 points. And very last one, okay, bit of fractional equations, okay. I'm going to times through by 15, only because I want to get rid of the bottom numbers. It'll make sense why I'm doing that in a second. If I times the first one by 15, times the second one by 15, and times this by 15, okay, what will happen is 15 divided by 3 gives us 5, so I end up with 5, x minus 3. On the second one, 15 divided by 5 is 3. On the third one, 15 just stays as it is, 15 times 6. Then all we've got is expanding brackets, we've got no fractions left. The fractions are the bits you want to get rid of. 5 times x is 5x. 5 times 3 is 15. 3 times x is 3x. 3 times 2 is 6. 15 times 6 is another one we want to simplify, so that gives me 90. 5x and 3x is 8x. Minus 15 minus 6 is negative 21, all equal to 90. Okay, once you're there, I'm going to add on 21 to both sides. 8x equals 111. And then I don't think this will simplify to give us a nice answer, so I can just write x equals 111 over 8 as an answer. That is worth 2 marks. Okay, so well done if you got that right. Right, guys, so moving very swiftly on to what we're doing today, okay? I don't want to waste too much time on the starter, but again, there's loads of key topics in there. Altogether, by there, there's probably about 30 marks, maybe more, of a higher tier paper, okay? Just on those topics alone. Right, guys, so proportionality, okay? The way this is written, okay, this is always a 5-mark question, always comes up, usually paper 1, okay? A is directly proportional to B when A is 6 and B is 2. Form an equation in terms of A and B. Okay, so they're not exactly the same. You can't write A equals B. So what you do is you write A is proportional to B. This sign by there is a proportional sign. It looks like a fish. It's a proportional sign. It means A is proportional to B. This is called the general equation. To form an actual equation, okay, you've got to replace this fish sign with an equals, but then there has to be a k that's a constant. Okay, now that tells us how much is proportional to B by. Okay, so A is proportional equals k the constant times by B. So they're not exactly the same, they're very, very similar. A equals KB. Once we're here, I know A is 6 and B is 2. So 6 equals 2k. If I divide through by 2, k equals 6 over 2, which gives us 3. So when it says form an equation in terms of A and B, I know A equals 3B. Right, guys, so I'll give you 1 minute. Can you get this one over here done, please? Similar format, okay? All you're doing is you're forming this equation. So you start with this. They're directly proportional, so you don't need to do anything special. A equals KB. I'll give you 1 minute, guys. Try and form an equation in terms of A and B for this question by here. Right, guys, so same thing over here, yeah? A is directly proportional to B. Okay, that's fine. And then I'll end up with the equation A equals KB, with K being the constant we want to find out if we're going to form an equation. Okay, I know when A is 20, B is 4. So 20 equals 4K. And if I divide through by 4, that'll give me a K value of 5. If K is 5, then the formula would have to be A equals 5B. So what it's saying is for every 1A you have 5 lots of B. That's essentially all it's saying. It's not as complicated as it looks, but this is an A or an A star topic. Get that copied down, guys. If you've done that one, that's bro. Now, what a full question will look like. What a full question will look like when it comes to proportion. Again, remember, if you miss anything, don't worry, it's going to be up all day anyway. What a full question looks something like this. A is directly proportional to B when A equals 15 and B equals 5. Form an equation in terms of A and B. We just did that a second ago, so we're going to do that for this question as well. Find the value of A when B is 4. That's always the bit they put on the end. This is worth 5 marks. So A is directly proportional to B. Okay, A fish sign B. That means A equals KB, with K the constant we want to find out. Okay, if A is 15, B is 5, so 15 equals 5K. If I divide through by 5, K would have to be 3. If K is 3, that means the formula we need to use is A equals 3B. So when whatever A is, you need 3 lots of B. They're saying find the value of A when B is 4. So if B is 4, I'm going to put that in. So the value of A equals 3 lots of whatever B is 4, 3 lots of 4. So when B is 4, A would have to be 12. Okay, it is literally that simple. It's a long-winded way of writing stuff. Okay, it is higher tier. So yours, when you come to the exam, won't be as nice as this. But this is direct proportionality. Guys, get this one down for me, this whole example on the left, and have a go at that one. I'll give you 1 minute. Again, if you don't think you've got time to get it down exactly as it is, either take a screenshot or wait until the end when it goes up live later on. Right, guys, so I'm going to go through this side as well. A is directly proportional to B. Okay, we're going back to the same A, fish sign B. That means our formula is going to be A equals KB. Okay, A is 30, B is 10, so 30 equals 10K. If I divide through by 10, K would have to be 3. So A equals 3B, so we got the same formula again, A equals 3B. Okay, find the value of A when B is 7. Okay, so I'm going to find A, substitute B is 7 into this. So A is 3 lots of 7, A is 21. So when B is 7, A is 21. It is literally that simple. What I'd like you to do for me, guys, can you, if you need to get that down now, or maybe at the end of the session, okay, if you haven't got time, or take a screenshot. Can you have a go at some of these questions by here, please? This is task 1. So this is similar to what it would look like for your exam, okay, if it was directly proportional. I'll give you 2 minutes to get a couple of those done. Right guys, so very quickly moving on. Okay, mark those for me. Okay, cool. Right, so indirect proportion, okay, very similar but slightly different. Okay, all it means is, again, back to the starter, it's the reciprocal of what we've got. So h is indirectly proportional to the square of b when h is 3 and b is 10. Okay, form an equation in terms of h and b, find the value of h when b equals 5. So if it's indirectly proportional, that means different to start, it's 1 over to the square of b. So h is indirectly proportional to 1 over b squared. Okay, once we're there, okay, we got to go back to what we did in the last one, is make a change the fish sign into an equals k. H equals k over b squared. And we want to find what k is, because that's going to be the constant to help us through the question. When h is 3, b is 10, 3 equals k over 10 squared. 10 squared is 100, times through by 3, k equals 300. K equals 300. We know our formula then for this is h equals 300 over b squared. Okay, I want to find h when b is 5. H equals 300 over 5 squared. 300 divided by 5 squared. 5 squared is 25. 300 divided by 25 gives me 12. So when b is 5, h is 12. Okay, and that links the two. Okay, so I'll start you off on this one. A is indirectly proportional to b. Okay, so all that means is A is indirectly proportional. So A is indirectly proportional to 1 over b. A equals k over b. Now you'll need to finish that off and find the value of A when b is 24. That's the final bit of the question. That's the important part. Right, so they say when A is 4 and B is 3, so A is 4 equals K over B, which is 3. So 4 equals K over 3. That would mean if I times through by 3, K would equal 12. Okay, I know my formula then is A equals 12 over B. They want to find the value of A when B equals 24. That means A equals 12, which is K, over B, which is 24. 12 over 24, that simplifies to 0.5 or a half. So when B is 24, A is 0.5. And that's it. That's all you're essentially doing on these ones. Right, guys, have a go at some questions for me. And then have a go at those. And then when we're done with those, I will go through a GCSE question. We'll have a go at a GCSE one to finish. So the first one, it'll look like y is inversely proportional to x. Y equals K over x. And you've got to go from there and you've got to find out value of y when x equals 8. I've started you off. Right, guys, so mark whatever you've done on that page for me, please. Those are your answers. Right then, so let's go through a GCSE question. So what would look like a GCSE would be something like this. Okay, so I'm going to zoom in just so we can see the different parts of the question. Given that G is directly proportional, scroll down, given that G is directly proportional to T squared, and that G equals, given that G is directly proportional to T squared, and that G equals 450 when T equals 7.5, find an expression for G in terms of T. So, G is directly proportional to T squared, so directly proportional to T squared. That would mean G equals KT squared. I want to find what K is. Okay, that's always my first step. So given that G is 450, K T squared, 7.5 squared. Again, you probably need a calculator on this one. I'm not sure where mine's gone. Let's see if I can find it. Right, can't seem to find a calculator, so what I'm going to do, I'm going to move on to the next one, which I don't think you need a calculator. You don't need a calculator on this one. Similar question. What I'd like you to do, guys, have a go at this one for me, and then I'm going to go through it in 1 minute's time. Definitely need to find my calculator for the next session. This is what a GCSE question, I think this is off one of the recent papers. This is what it would look like. Right, guys, so I'm going to go through this one, okay? So given that y is inversely proportional to x, so y inversely proportional to x, and that y is 4 and x is 3, okay, so that means y equals k over x. That's going to be our formula. We need to find k, find an expression of y in terms of x. That's what we're going to do, okay? I know y is 4 equals k over x, k over and x is 3. Times through by 3, that means k would be 12. So my expression, y in terms of x, is going to be y equals 12 over x. That's my expression for 3 marks to start us off. I think this is off one of the recent GCSE papers as well. Y equals 12 over x. Down the bottom, use the expression you found in A to complete the table. Okay, so in the first one, we're missing the y value. Okay, so we're missing the y, and we know the x. Okay, so we know x is 0.25, y we don't know. So y equals 12 over 0.25. How many quarters go into 12? Well, 4 quarters go into 1, times that by 12, it can be 48. So when x is 0.25, y equals 48. Again, on the next one, when y is a fifth, what's x? Okay, so when y is a fifth, so y 1 over 5 equals 12 over x. Okay, once we're here now, I'm going to change that fifth, I'm going to change that to 0.2. Okay, and the nice thing about solving equations, you can just swap those two around. So when y is 0.2, what's x? If we swap those two around, x equals 12 over 0.2. Don't want that. 0.2. 12 divided by 0.2. Well, 5 0.2s fit into 1. Times that by 12. X has got to be 60. So when y is 1 over 5, x is 60. Okay, and this does work because inversely proportional means when one of them is big, the other one's got to be small. That's big, that's small. And that's what inversely proportional means. Okay, guys, well done if you enjoyed this session, guys. I know it's not an easy topic at all, and I'm really, really proud of all of you for all of your hard work so far. Well done.